Hello everyone, today we are going to see question from GFG, largest subarray with sum 0. And with this, we are also going to see the standard patterns to solve this question, which question is going to be longest subarray with sum k. Okay, so let's read the question. The first one being, given an array ARR containing both positive and negative integers, the task is to find the length of the longest subarray with sum equals 0. Note, a subarray is a contiguous part of array formed by selecting one or more consecutive elements while maintaining their original order. Okay, so in this video, I'm going to discuss two methods to solve this question. Okay, so let's discuss what the question actually demands. Basically, the question demands us that we have to find a contiguous part of array, which is going to be a subarray, which is going to have a sum is equal to 0 or k. Okay, so right now, I'm going to discuss the brute force approach to solve this question. These are the constraints from GFG, where you can see 10 to the power 6 into 10 to the power 3 is going to be 10 to the power 9. So this all can be constructed inside int. So we don't need a long here. Okay. Next, this method is going to take a time complexity of O of n square and space of O of 1. Let's see what the steps are. First, we'll utilize a loop to pick the first starting point for the subarray. Okay. Next, we'll initialize sum to 0 and we'll introduce another loop inside this. In this loop, we are going to calculate the sum for all possible subarrays from the starting point, and then if we found a sum equal to 0, then we are going to update the global maxi, which is going to store the maximum size of the subarray. Okay, so for each position, we'll construct the subarrays from that starting point. Okay, so this is a very simple one. Next, you can see the visualization for this method where we'll start from 0 comma 0. For the first index, you can see the sum currently is going to be 1. J is going to proceed, J being the nested inside loop, which is going to proceed to increase the size of the subarray slowly. So you can see it increased by 1, so sum still stays as 1. Next, the value is -4, so sum becomes -3. So on and so forth. You can see this condition. You can see 1 plus 0 plus -4 plus 3, which is equal to 0. So sum reaches 0. Hence, we are going to increase the size of maxi from 0 to something. So something being j minus I plus 1. You can see there are total 4 elements inside this subarray. And to calculate the size of the subarray, you have to use this formula where j minus I plus 1 gives 3 minus 0 plus 1, which is equal to 4. And so on and so forth. You can see for all the iterations. Next, we'll have iteration from this index. So as we finish the iteration for j, we have to increase the size of I. Okay, so we start from here, and slowly we are going to increase the size. And you can see at this point we have sum equal to 0, where 0 plus minus 4 plus 3 plus 1 is equal to 0, but still the size is 4, so maxi remains same. But after this iteration, you can see here that after considering all the all the last 5 elements, you can see the sum is still 0 and the maxi is 5. So this way, the iterations are going to take place, and there will be future iterations. But since we got a maxi 5, the possibility of getting a larger subarray is very minimum. Okay, so that's it. Let's code this one. So in this method, first we'll need a global variable to store our maximum value. So int maxi, I'm going to initialize it with 0. Next, we'll need a for loop. So for int I equals 0, I less than n, I plus plus. And yeah, I have already initialized n as utility. Okay. Next, we'll need a sum. So int sum equals 0. And after this, we'll need all the subarrays from this starting point I. So for int j equals I, j less than n, j plus plus, sum plus equals to ARR of j. Okay, so we are adding values of a or of j, and if any point of time, if sum equals 0, at that moment we have to update maxi. So maxi is equal to max of maxi comma, so the formula being j minus I plus 1. Okay, so this is going to give us total number of elements in that subarray, and in the end you have to return maxi. So this should be the brute force approach. Let's run this. Okay, let's submit this. And you can see there's just one test case that we failed. We got a TLE. So our approach is correct, but it's taking a lot of time. So next we'll move towards the optimization of this problem. So now let's see the optimization part for this problem. In this problem, we are going to use prefix plus hash map to optimize this problem. Let's see how. So you can see the same subarray and the same constraints. The complexity for this method is going to be O of n, and space complexity is going to be O of n. Let me tell you why this approach. In this approach, we are using this prefix plus hash map. Okay. First thing first, you can see this array is not sorted. Okay. The question does not guarantees that the array is going to be sorted. Hence, 2 pointers out of equation. Second, you can feel that we have to calculate a subarray. Hence, you can think about a sliding window. But you can see that the array also consists of negative values. So the array is not consistent with positives and negatives. So you can see in this condition where I have an array or subarray of size 2, so the current sum is 1. If I increase the size of the subarray, the current sum is going to be minus 3. So literally I have increased the size of the window, but the sum decreased. So it's not monotonic, or it's not consistent with the pattern. Hence, what I'm going to do is I'm going to think about something else. So you can see that I need the sum of subarrays. So I have one condition where prefix sum is one of my options. In my previous videos, I have discussed that we can calculate the sum of subarray from I to j using prefix in this format, where prefix of j minus prefix of I minus 1 gives the sum of subarrays. Okay, so you can see that the sum of subarray is prefix of j minus prefix of I minus 1. In this question, we need the sum arrays with sum 0. Hence, we'll need the prefix of j minus prefix of I minus 1 equal to 0. After rearrangements, prefix of j is equal to prefix of I minus 1. So, in turn, I have to store the older prefix in some place, and I have to access it so that I can calculate how many elements were between these two prefixes. Okay. So the main problem now is, how do I find that the prefix already existed? So to solve that problem, I'm going to use a hash map. So the hash map is going to store the prefix values and the index at which they occurred. Okay. And I'm not going to update the hash map for the recurring values because it's going to smallen my subarray. Rather, I'm going to keep the first occurrence only. Okay. So the steps to follow in this method are: first, we'll have a hash map initialized to store the prefixes of the first occurrences, and we'll have a prefix variable. I'm not storing the prefix subarray or the array, rather I'm storing just a variable to store the prefixes. Next, I'll traverse over the array and I'm going to increment the prefix, and then I'm going to check. Okay, these three conditions. First, if this is isolated one, where if prefix is equal 0, then you can directly assume that the maxi is going to be I plus 1. The maxi going to be the largest subarray, okay, with sum 0. So it's going to be I plus 1. You can see in this condition, if 1 plus minus 4 plus 3 plus 0 is equal to 0. Okay. So I'm going to store I plus 1. This is guaranteed to be largest, so there's no need to check here. Next, these are the two conditions for hash based. Okay, so first, if we hit the hash map, okay, if we find a prefix which already existed, then we are going to update the maxi using conditions. Else, we are going to store this MP of prefix is equal to I. So this is a new prefix that we hit, hence we are going to store it for future uses. It's possible that this prefix, the storing of this prefix help us to find the largest subarray. Okay, the third part is going to be returning the maxim. Okay, so let's visualize how this method works. First, we had this array. For the first element, the prefix is going to be 1. The max is 0 because we have not received any element which has a prefix is equal to 0 or the subarray of sum equal to 0. So the size current is 0. So the you can see the prefix is equal 0. No. MP of find prefix, no. Hence we are going to store prefix of MP of prefix is equal to I. Okay, so MP of prefix is equal to I. I is going to be 0. Next part, we reach 0 and you can see we hit again a prefix equal to 1. Okay, so we hit again prefix equal to 1. So you can see it hits this condition where mp.find is not equal to mp.end. Hence we are going to update maxi. So you can see this is the condition where j is equal to 1, I minus 1 is equal to 0. So this is the condition. Hence we are going to update maxi. So you can see we are storing this one subarray, which is our largest subarray with some 0. Okay. Next, we'll have this next element whether it's going to update the prefix is equal to -3. So we are hitting this condition, prefix storing a new prefix with first occurrence. Okay, so this is the case for first occurrence. Next, you can see here we reach 3. Okay, now the prefix is equal to 0, and prefix is equal to 0 has a special case where maxi is directly equivalent to I plus 1. Hence, we're going to keep maxi is equal to I plus 1. Plus, this second loop is still going to, or the second if condition is still going to be implemented. So it's going to store prefix of 0 is equal to I. Okay. So prefix of 0 is equal to 3. Okay. Next part is this one where we received a prefix is equal to 1. Again, okay. So this is this mp.find is not equal to mp.end case. Hence, we are going to update maxi. The older maxi is 4. You can see to update the new maxi, we are going to use this formula where it's going to be I minus MP of prefix. Okay. So this is going to be a case to find the new maximum subarray if possible. So either the older maxi or this one. Okay. So in this condition, you can see the size still remains same. Okay. So this is the part where we have prefix of 4, which is this one, and prefix of 0, which is this one. So prefix of 4 minus prefix of 0 is equal to 0. Okay. So still the size is 4. So for the next iteration, receive the 0 and prefix is still 1. And hence, you can see now in this case, this is the same from the last one, but this time it's prefix of 5 minus prefix of 0. So 5 minus 0 is going to be 5. Hence, the maxi is 5 in this case. Okay. So let's code this one. First thing, I've already put maxi over here and we have return maxi in return case. So we need to initialize a prefix. So prefix is equal to 0. Next, we'll need an unordered map to track first occurrence. So int comma int, let me name it as mp. Okay. Now we'll run a loop throughout all the variables I less than n, I plus plus. So first step is going to be prefix increment. Okay. So prefix plus equal to ARR of I. Next step is going to be the condition where prefix is equal to 0 equals 0. So if prefix equal 0. Then we are going to do maxi is equal to I plus 1. Okay. Third case is where if we hit inside the hash map. So mp dot find prefix not equal to mp dot end. Okay. So in that case, we are going to update maxi. So maxi is equal to maximum value of maxi comma I minus mp of prefix. Okay. And the third case in the else case is going to be mp of prefix is equal to I. So uh, this is the hash map hit and hash map store. Okay. So these are the three conditions. Let's run this. Okay, let's submit this. So you can see we have solved this question using of and time complexity. Okay. Now we are going to discuss the standardized method or for the sum equal to k. Okay. So we have already discussed the largest subarray with sum 0. Now we are going to discuss a parallel question which is going to be longest subarray with sum k. I have copied the same code from the last one, but I have made some edits. So you can see it was 0 already in the earlier one. Now it's k. So in the last part, we need longest subarray with sum 0. In this one, we need a longest sum a subarray with sum k. Hence, we have to check if the current prefix is k, then we can directly update the maxi to I plus 1. Second part is being that for prefix I minus k rather than prefix inside the hash map, you don't have to find prefix directly, you have to find prefix minus k. And it's the same part over here. Why? Let's see here. So earlier we had prefix of j minus prefix of I minus 1 equals 0. But in this new question, we have this condition where prefix of j minus prefix of I minus 1 is equal to k. Okay. So the prefix of j is equal to prefix of I minus 1 plus k. I've shifted this one. And in the end, we read this condition where prefix of j minus k is equal to prefix of I minus 1. Okay. So this basically means that the older one is going to be new minus the k part. Okay. So I've written the same stuff here, that prefix of okay, sorry, this one, the prefix of prefix of j minus k is equal to prefix of I minus 1. So we are finding prefix of I minus 1. If we found prefix of I minus 1, then we can update the maxi. Okay. And the third thing is going to be if we don't find this prefix inside the hash map, then we are going to store it inside this hash map with new entry. Okay. So let's run this. Okay. Let's submit this. So you can see we have solved this question using prefix sum plus hash map. Okay. Thank you.